Very good. A good day to everybody. So this is the presentation of the use cases and functional requirement of an extension of a standard that was approved in September last year that is called multimodal conversation. We have 4 speakers, myself, Miran, who is the chair of the group that develops this standard, Mert, Mark, and Jaime. What is media coding standard? Well, it's been a success story because they have enabled the success of digital media. And MPAI intends to do the same for data coding by artificial intelligence. It targets AI-enabled data coding standards, and by data coding we mean transformation of data from a format to another that is more suitable for an application. So how do our standards work? Our standards are component-based, so we assume that they are AI modules. AI modules can be at the atomic level, but they can be composite AI module in the sense that they contain themselves AI modules. And then we have an AI workflow, which is a combination of AI modules structured to achieve a certain goal. So this is the first element. So we said that we have an AI workflow made of AI modules. The workflow is defined by the input, by the workflow itself, which means the function, and the topology of AI modules, and by the output. This is executed in an environment where we have a controller, we have communication, global stores, access, MPAI store, and so MPAI standards specify the components and their integration. Next point is, which is critical for the success of standards, standards have to be usable. Standards should be based on advanced technologies. Advanced technology has been the result of a significant investment. This investment have to be protected rightly, but the standards eventually have to be accessible in a timely fashion. Therefore, before initiating a standard, the active principal members develop and adopt a framework license. This is a license without values. You will not find how many dollars, what is the percentage, is the date that something starts. And the framework license will declare that the eventual license will be issued at a price that is comparable with similar technologies and not after products based on the standard are on the market. During the development, any member making a contribution declare it will make its license available according to the framework license. And finally, after the development, the members who hold IP select the preferred patent pool administrator. We have developed so far 5 standards, and the multimodal conversation is the one where we focus our attention. It contains 5 use cases, but actually we have 2, one which is conversation with emotion and multimodal question answering, and then we have 3 automatic speech translation use cases. What we do now, we intended to start 3 new standards. 2 are continuation of existing standard. The AI framework will add security support to the framework that I have described, and the multimodal conversation will contain 2 composite AIMs. We believe that these are very important elements to build an ecosystem of machines talking to humans, and the 3 use cases. So how do we develop standards? We start with interest collection, we develop use cases, we define functional requirements, and this is where we are today. we have functional requirements available and use cases. And from now on, we'll develop the commercial license. And on the 19th, the Coulter technology with the functional requirement and the commercial requirements will be published. And we expect to have responses, proposals that will enable us to develop the standard by the 10th of October. Then we have a phase where we ask the community what they think about the standard that we have developed before the standard is finally approved. And this is very interesting because we do receive interesting comments that allow us to fine-tune the standard. And finally, the standard is approved. So what is the purpose of this presentation? It is to provide the very general highlights of the MPAI-MMC version 2 standard that we are about to develop. We request proposal for data formats and technologies. And we also have in mind to encourage participation in the development of the standard. So we have presentations on the personal status, conversation about a scene use case, personal state display, human autonomous vehicle interaction, audio scene presentation, avatar-based video conference, and automatic speech translation. And finally, what will be next. And here we have the speakers, Mark, Jaime, Milan, Mert, myself, yes. And because of that, I think that we are at the first element that will be presented by Mark. It is about the personal status.
Well, thank you, Leonardo. Here's the story. When you interact with people, either to understand them or to portray them, there's no way to avoid analyzing what they're feeling, what they're thinking, how they present themselves to the world. And that'll be the case even if that interaction is artificial, even if it's carried out by programs. And obviously, that kind of analysis is an unlimited task. It's the task every novel undertakes, every psychology and sociology text ever written. But MPAI faces the task of standardizing approaches to this kind of analysis all the same. So we have made a brave beginning, knowing all the time that there is no ending. We define a personal status as a combination of emotion, cognitive state, and attitude. That means roughly what you're feeling, such as anger or sadness, your cognitive state to the extent you can separate that from your feelings, such as confused or convinced. Although, you know, there will always be overlaps as when you're both surprised and happy. And the social stance that arises from your feelings and your cognitive state, such as resentful or polite. And it's true that the separation of these three aspects of personal status is somewhat artificial, but again, we don't have any choice except to make an attempt, knowing that refinements and adjustments are always to be expected. So how do you show your emotion or your cognitive state or your attitude? You do it through several modalities. What words you use, what you might write, what you say, since your voice might carry information that's not in the actual words or the surface language, and through your face and your physical gestures. And last week I made the joke, especially if you're Italian, which I can't resist repeating. So we've designed a composite AI module, a module composed of several smaller modules called personal status extraction, where extraction implies analysis, in this case, rather than portrayal. And you'll notice first the inputs on the left and the output on the right. Once again, we're analyzing the personal status of some real or artificial person. What goes in is the modalities I just listed for a given person. What should come out is a unified description of the personal status as a whole. And in between, we have modules that extract low-level features for those modalities, modules that interpret the low-level features, producing interpretations that feed a module that combines or or fuses the interpretations, finally yielding the overall personal status. Next slide, please. And what's in that overall personal status? Well, it collects or summarizes the results of the analysis steps I was just describing. There's the fused evaluation of the status, its elements, the relevant emotion, cognitive state, and attitude per the modalities, and also included are indications of the confidence or accuracy scores for the various steps. The low-level features themselves are also included in the summary. We do have continuing questions about the best way to express a stream of changing personal statuses or stati. And but meanwhile, we do have standard ways of representing emotion. So let's see the next slide here. This is the JSON syntax, which is now proposed, which just gives the name of the emotion and so on. The degree of the emotion, such that you can be somewhat sad or very sad. One point of interest is that emotions come in sets, and those sets are subject to augmentation or to replacement. So you can notice the emotion set name at the bottom of the slide. Next slide, please. The representation of an emotion includes its name, its degree, its ID within a given augmentable or replaceable set of emotions, and the name of that set. Going on. Here's a partial listing of emotions. And as I said before in my disclaimer, there's no end to this, but our beginning is that we have a listing of emotion categories in the left-hand column, such as anger, and those categories correspond to general or high-level adjectives like should be angry. I see a typo here. And then more specific adjectives like furious or irritated or frustrated, and so on for these various other categories. Going down to the bottom, happiness with the adjective happy, and more specifically joyful, content, delighted, amused. Next slide, please. So for each of these emotions, we have a meaning, the semantics of that emotion. So in the case of amused, number 2 here, we have a gloss, positive emotion combined with interest, which is a cognitive matter. For anger, actually, as I said before, it should be angry. That's an emotion due to perception of physical or emotional damage or threat. This is our best attempt at the moment to say what angry means. I think that does it for me. Thank you.
Okay, very good. So let me go to a conversation, and Jaime will introduce this part.
Thank you, Leonardo. There are several types of conversation, including the human with the machine. And in this conversation, the meaning is conveyed not only through the voice, but also through the various body gesture and facial expression. However, I think the conversation with the human is machine has not developed significantly in machine yet. So main purpose of the MMC standard is defined to how to make a better conversation between the computer and human. They should be able to communicate with, understand each other by considering not only the contents, but also the human emotions and feelings and facial expression and gesture. Next. For example, recent years, many artificial intelligence devices appears on the market in order to correctly understand and communicate the people intentions. Many technological achievement and industry effort to analyze the data and in progress. In fact, recently, some humanoid robots are also being distributed, and in future, these robots are expected to take on the roles of housekeeper and security and assist various aspects of our daily life. Hence, we want to the good position to have in this kind of situation by providing the standard for the commercial side and as a robot and smart device to improve the human's life. Next one, please. So last example is during the COVID-19 crisis, there are many cases of non-face-to-face discussion. So in virtual meeting are routinely held. In this meeting, the feeling or status of the participation are often mispresented and it leading to the misunderstanding and an inability to reach clear conclusion in discussion. So we need to find better way to prevent this kind of the not good situation and improve the method to understand each other via technology standard. Next, please. So that is one of purpose of the why we are developing the conversation about the scene use case. And let me introduce the specification and scope of the conversation about scene. A human hold a conversation with a machine about the object in scene, use gesture to indicate object. The machine is see the scene and hear the human and understand what the human is saying, improve understanding of the human internal status by extracting by the human personal status, understand the intended object through the gesture of the human, understand the text and produce the response with its own personal status, and manifest it itself and as a speaking avatar. And the last one is display on a screen the scene as it understands it. And reference model is mandatory of the MPAI standards, so we must make a workflow of the architecture of this use case. So let's see the details of each module. And first one is visual scene description, produce the human object and physical object from input video, and gesture description produces gesture descriptor from the gesture descriptors, and object descriptor is produce object descriptor from object. And object identification is proceed object ID from object descriptor. And the other side is one of the input of speech, and speech recognition is producing the recognized text to input speech. It comes into the personal status and language understanding. And language understanding is produced the meaning and language understanding text from the personal status, recognized text, and object ID. The language understanding module is responsible for the transforming various information received from input like natural language conversation, grasping the meaning and passing on it next module. And last one is catch and dialogue processing, produce the output text and personal status, speech, and personal state face and personal state gesture from the personal status and meaning and language understand text. These the next step is the personal status display. Yeah. Additionally, in this table, we can see the various input and output data and AI module. When we defining use case, we must also organize it to detail of the data type and module. So I don't want to explain the details. It is over covers it previously. So please go next step. And lastly, I'd like to explain the more technologies for the conversation about a scene and visual scene descriptor, including the human object and face object and generic object, and object descriptor, including gestures and generic object and recognized speech and generic object ID. And lastly is meaning. That's all. Thank you.
Thank you, Jaime. Mark, you are back.
Yes, I'll chime in again. Now we come to display as opposed to analysis of a personal status in order to portray people and their emotions, their cognitive states, their attitudes through the various modalities that we saw earlier. So input for this display would include the text to be uttered and descriptors of the speech with what emotion, what attitude, etc. The description of the face and of gestures. And the output will be the dynamic actions of an avatar. What it says, the words it says, its speech itself, its face, and its gestures. And the speech will be modulated via emotion-enhanced text-to-speech, speech synthesis. Its face and gestures will move appropriately. And this is a portrayal of more or less the same thing. On the left, you see the inputs that go into portraying a personal status, the text, and the other modalities. The three green boxes are the modules that produce the speech synthesis, the face synthesis, the gesture synthesis, and what comes out is the appropriate text, speech, face, and gesture. Thanks.
Very good. So, Milan, it's your turn. Actually, before that, let me make a brief introduction of the project. We have a project called Connected Autonomous Vehicle. It is composed of subsystems. One is the subsystem that interacts with the human. Then we have the brain of the autonomous vehicle called Autonomous Motion Subsystem. Then we have the environment sensing subsystems, which is one that acquires all available data from the environment to understand the environment and position the vehicle inside. And one source of information comes from a subsystem that is called motion actuation subsystem, which is, of course, actuated by the autonomous motion subsystem after it has gotten more information from other vehicles or other communicating devices. So having said that, Milan, the stage is yours.
Okay, thank you, Leonardo. So this is the human and car interaction part. So this subsystem recognizes the human who has a right to the car and responds to humans' comments and questions. It provides environmental presentation for humans to use and senses human activities during the travel and may activate other subsystems as required by humans. So this subsystem consists of many AI modules. So from left to the inputs are from the user agent and also from the environmental sensing subsystems. So from the top, the input from the outside audio and text and outside video will go to the audio scene description, and that produces speech. And the speech will be described by the speech description module. And it is also recognized as a text by the speech recognition module. And then the speech descriptors will be used by the speaker identification, and it produces the speaker ID. And the text recognized by the speech recognition and the speech itself, and then the face object from the visual scene description module that will be used by the personal status extraction, and it produces personal status. And also the object description will produce the physical object descriptors that is used by the object interpretation, and it will produce the physical object ID, and the same as the face recognition. So the face ID will be produced, and it will be used by the question and dialogue processing module with other input from the language understanding module, like meaning, personal status, and text through the language understanding AIN. So finally, the personal status display will use the personal status from face, gesture, and speech, and also the alt text, and it displays the machine face, machine gesture, and machine text, and machine speech. Next slide. So what we need for the technologies for human cop interaction. So we need audio scene descriptors and speech descriptors for speech recognition, face descriptors for face recognition, and speaker ID and face ID.
Okay, and so Milan highlighted the importance of the AI modules called the audio scene descriptors. And so this is not an area that MPAI is new, but we wanted to do more. And in particular, the challenges come from the connected autonomous vehicle, and Märta will say more about these issues.
Hello, I will talk about audio scene description. First of all, I will make a small comparison with the visual scene description. For the visual scene, we will just identify the objects with a single camera, then we can localize the objects with pixel locations. But here, with an audio scene, the location of the audio objects can be just localized by using multiple microphones, and its name is the microphone arrays and different orientations. Here, audio scene description is a technology for, first of all, detecting the speech objects which are emitting sounds in the environment, and then after obtaining their locations and separating the speech sources, that would already, we can obtain the pure speech signals that can be used for the use of other AIMs. And the mixture can be meaningless for some other AIMs like speech recognition and also translation parts. And audio scene description is can be designed as a composite AIM, which has an input with microphone array recordings as multi-channel audio, and the output is needed for the speech objects and their locations. We can say that the speech objects are located with an azimuth elevation and distance according to the microphone array reference point. Then they will already be packaged with the speech objects and locations are packaged for other AIMs. Can we go to the next slide, please? The problem is the well-known problem. It's the cocktail party effect. It's in a cocktail. There are multiple speakers. They are already speaking in an environment. But if we just record the scene with a single microphone, then we will obtain a mixture of speech objects, and it's hard to localize, and it's not possible to localize the speech objects with a single microphone. Then already the separating the speech sources is already is not simple. Therefore, here we are using the microphone arrays that's located inside the room, or it may be outside environment. Or, for example, for the autonomous vehicles, they can be located in the roof top of the vehicle. Then, by using these microphone array recordings, it's the multi-channel audio with the number of microphones that are positioned over the environment. Then this AIM is designed to obtain or designed to output the speech object 1 and their locations, and object 2 and locations, and the other objects. We would already separate the signals and give the signals in different channels that can be applicable or that can be useful for other AIMs. Next slide, please. Now, first of all, here, the recording positions or recording microphone positions can be changed according to the geometry. It may be, as I said, that for autonomous vehicles, they can be located at the rooftop of a car. It can be like in circular, in spherical or linear coordinate system. And the microphone array type can be an open, and it can be a rigid body that the microphones are positioned over the array. And already they have multiple number of microphones. For example, in commercial microphone arrays, they have up to 64 microphones, and the sampling rates can change according to the signal processing algorithms or AI modules. They can be just modified, and there will be an input that can be already given with the microphone array geometry to this AIM. Now we are working in the MPAI-CAED, and we are developing the standard for enhanced audio conference experience. In this enhanced audio conference experience, we have AINs that can be already useful for audio scene description, and they can be cascaded to obtain from input to the output relations. Then we can use the analysis transform, sound field description, and speech detection and separation, synthesis transform, and packager we will use to just obtain this audio scene description. Since we are working at the outside environment, then we say that it's not reverberant so much, and also there is so little noise outside. Then if there's a noise in the platform and there's a reverberation, we would already add here noise cancellation part, and that will the cascaded AIMs can just obtain with a workflow of this audio scene description. Thank you very much.
Thank you, Matt. Let me now be the speaker. So we have another use case that is a greater receptacle of useful technology, useful and reusable technologies in different use cases. So here we have what we call avatar-based video conference. We have groups of humans at different locations participating in a video conference, but not participating themselves, but through their avatars that represent them in an accurate fashion. The system is composed of 4 elements. The first is the transmitting client. That essentially the role is to send the avatar descriptors and the avatar model. Then we have a server that performs essentially translation, but also authentication of speakers via speech and face. Then we have the virtual secretary, which is capable of summarizing what are the avatars, i.e. the humans behind the avatars are saying, and allowing the avatars to comment and act changes to the summary. Finally, we have the receiving client, where a participant can arrange the avatars around the room, around the table, as he or she sees fit, and can sit at the table at the place of the avatar and have the visual and audio experience of the avatar, or can navigate the space for different purposes. So I have already given sufficient description, so I won't say more. So I just wanted to focus on this transmitting part of the client, which contains an audio scene description. As Matt have said, that we can have more than one participant in the room. So the purpose is to extract the speech of this individual participants, do the same with their visual appearance, and describe the avatars that represent the individual participants, so that participants can use their own receiving client and create their own meeting room. So this is a breakup of the components. We have the audio scene description, the visual scene description. Here we have the speech recognition. Here we have the extraction of description of face and gesture. And here we have the descriptors of face and speech for authentication purposes. And then we have the language understanding block. And finally, the avatar description block. As I said, we have the server here, and we have the component of participant authentication, but we have also the component called speech translation. This is something that we have partly done in version 1, and therefore Mark is called again to defend what he has done in the previous standard.
Therefore, here I am. There are basically 3 stages in speech-to-speech translation. MPAI is envisioning several different use cases for speech translation, but the simplest is unidirectional, in which the first stage is speech recognition, which produces text, and then that text has to be translated from one language to another, and maybe several different languages. And finally, based on the translated text, we have the speech synthesis in the output language or languages. One interesting thing is a 4th box in this picture, speech feature extraction that you see at the bottom, in which we pull out features of a given person's speech with the potential of transferring those speech features into the synthesis of the output language, so that it would sound as if I am speaking fluent Mandarin, although I don't speak fluent Mandarin, or fluent Turkish or some other language, by carrying across the features of my voice. Thanks, Leonardo.
Okay, good. So let's go to another very exciting area, which is called the virtual secretary. So here we have an avatar, and this avatar has the task of extracting the personal status of the other avatars, which, by the way, are not avatars, but are humans. But the extraction that the virtual secretary does is on the avatar, not on the humans. And then we have the usual pieces, the language understanding, the question and dialogue processing. We have also the personal status display, the usual component that is used to manifest an avatar as something perceivable. And then we have this interesting new element that is called summarization. And summarization is done using the meaning, using the text from language understanding, and using the personal status of each speaking avatars. Then a summary is produced. The produced summary is displayed so that the avatars can see and check if there is something that has been inappropriately transcribed, and therefore there can be a conversation via text between the virtual secretary and the avatar, the result of which is an edited summary that is brought back into the summarization AIM and displayed to all avatars. Finally, we have the receiving client. As I said, each participant arranges the avatar around the table in the way that he or she thinks appropriate, but the audio scene and the visual scene, when immersed in that scene, do correspond to the arrangement that has been created, which means that if I have placed an avatar on my right, I will hear the avatar speaking, and the sound will come from my right. So we have another long list of technologies here that we have. We have the environment model, various face descriptor, gesture description. We have the avatar model, the avatar descriptors, the summary. And there's two things that are important to note, and that is the environment model, the avatar model, and the avatar descriptors should allow a party to reconstruct the environment and the avatar using models and descriptors without access to additional information. So this may look a bit abstract, but converted in language that is current today is an environment avatar in Metaverse 1 can be imported into Metaverse 2, which means we have full interoperability between metaverses. So this is one important set of requirements for the technologies that are listed in this table. So I am coming to the end of the presentation. So what's going to happen next? The first is, as we said at the beginning, we are we intend to develop 3 standards. The first is the AI framework, which is already a standard, but we wanted to give security support to that framework. Second, we have the multimodal conversation standard, which exists. And we have a long list of technologies that we want to add because we have interesting use cases that we want to support. And finally, we have the neural network watermarking project. And by the way, if anybody at this meeting would like, I cannot say to stay over because the URL will change. But if you wanted to subscribe to this other presentation, you can hear what we plan to do on the neural network watermarking, which is not a standardizing watermarking technologies, but is to provide the methods, the procedures, maybe data sets that can be used to assess how good a neural network watermarking technology is. So the process is, so we have the use cases and functional requirements approved, and that is what we have presented. Then the principal members will deliver the framework license. On the 19th of July, MPAI will publish the call for technologies, use cases, functional requirement, and the framework license. By the 13th of September, respondents are kindly requested to help us manage the submissions by informing of their intention to make a submission by the 13th of September. So this is not an obligation. If you did not inform us of your intention, but you make a submission, the submission will be retained. And similarly, if you have told us that you wanted to make a submission, but you don't make a submission, that, well, okay, we will not be happy, but we will accept that. Then on the 10th of October, submissions are expected. And on the 12th of October, at General Assembly number 25 of MPAI, we will kick off the evaluation. The intention is to develop the standard during spring 2023. So this is the end of my call. Join the fun, build the future.